Okay, so imagine like a magic trick, right? But you only get to see the very beginning and then the end.
Mm-hmm.
The exciting part, the real secret, is all those steps in between that you don't see.
Right.
That's kind of what we're diving into today, reactive intermediates.
Okay.
You sent over some fascinating research on these fleeting molecules,
Mm-hmm.
and we're going to try to help you understand why they are so important,
Right.
even though they only exist for milliseconds.
Well, what's really fascinating about these reactive intermediates is that they're like these hidden players in the middle of a chemical reaction.
Okay.
So they're formed during the reaction, but then they disappear almost as quickly as they appear.
Wow.
They're full of energy, ready to react, but very short-lived, which makes
Yeah.
them very difficult to study, but also crucial to understand.
So they're like, I don't know, kind of like the missing link in understanding how a reaction actually happens.
Exactly. That's a great way to put it. It's like if you want to understand how a cake is made, you can't just look at the ingredients and then the final product.
Right.
You need to understand all those steps in between, like mixing the batter and all the chemical reactions that are happening in the oven.
Right, right.
Reactive intermediates are like those crucial steps, the ones that determine how that final product is formed.
Okay, that makes sense. But to really grasp this, can we maybe like break it down a little bit further?
Sure.
What exactly are reactive intermediates? What makes them so special?
Well, they're high-energy molecules that are unstable and extremely short-lived.
Okay,
And take radicals, for example.
okay.
These are molecules with an unpaired electron, which makes them highly reactive because they're constantly searching for another electron to pair up with.
So they're like, I don't know, like those people at a party who can't stand to be alone are always looking for someone to chat with.
Yes, that's a great analogy.
Uh-huh.
And then you have carbenes. These have a carbon atom with only two bonds and a lone pair of electrons, which makes them also incredibly reactive because they're looking to form more bonds to stabilize themselves.
So we've got these party animal molecules zipping around in the middle of a reaction.
Yes.
But how do scientists even know that they exist if they disappear so quickly?
Right.
It just seems impossible to study something that's gone in a flash.
Right. Well, that's where the magic trick analogy comes in.
Okay.
To understand the trick, you need to see those hidden steps.
Right, right.
Well, scientists have developed some pretty incredible tools to catch these fleeting molecules in action.
So,
Think of them as like high-speed cameras for the molecular world.
that sounds pretty high tech.
Yeah.
Are we talking about some kind of super-powered microscope here?
Not exactly.
Okay.
We're talking about techniques like electron paramagnetic resonance,
Okay.
or EPR,
Yeah.
which is great for studying radicals because it uses magnetic fields to detect those unpaired electrons we talked about.
Uh-huh.
Then there's femtosecond spectroscopy,
Okay.
which uses incredibly fast laser pulses to actually capture snapshots of reactions happening on a timescale of like a fraction of a billionth of a second.
Wow, a billionth of a second. That's mind-boggling.
It is.
It's like, I don't know, like taking a picture of hummingbirds' wings mid-flap so you can
Yeah.
actually see these reactive intermediates, even though they only exist for such a short time.
Exactly.
Wow.
These techniques allow scientists to study their structure, their behavior, and ultimately their role in driving a reaction forward.
This is really making me rethink how I even view chemical reactions.
Yeah.
It's not just about those starting materials and the end product.
Right.
It's about this whole hidden world of these fleeting molecules that are basically orchestrating the entire process.
Absolutely. And by understanding these reactive intermediates,
Yeah.
scientists can unlock a whole new level of control over these reactions.
Okay, now that we know how scientists actually study these fleeting molecules, let's explore how this knowledge translates into real-world applications.
Sure.
What can we actually do with this understanding?
That's where things get really exciting. By understanding how these reactive intermediates form, react, and disappear, scientists can manipulate them to create more efficient synthetic routes.
So we're talking about like designing new ways to make things, like medicines or materials,
Exactly.
by controlling these hidden players in the reaction.
Precisely. And because they're involved in so many different types of reactions,
Yeah.
the potential applications are incredibly diverse.
Can you maybe give me like a specific example of how understanding a reactive intermediate could lead to something really beneficial?
Absolutely. So imagine you're a scientist trying to develop a new drug to treat a specific disease.
Okay.
You've identified a molecule that has potential, but the current method for synthesizing it is inefficient and produces a lot of waste.
Right.
By understanding the reactive intermediates involved in that synthesis process, you might be able to design a new route that's more efficient. uses less energy, and produces fewer byproducts.
Well, it's like finding a shortcut in the recipe, a way to make the cake faster and with fewer dirty dishes.
That's a great way to put it.
Uh-huh.
And that's just one example. The potential applications of this knowledge are vast, ranging from developing new catalysts to designing more sustainable industrial processes.
This is truly incredible stuff.
It is.
It makes you realize there's so much happening at that molecular level that we often just take for granted.
Absolutely. And the more we learn,
Yeah.
the more we realize how much more there is to discover.
Right.
It's a never-ending quest for knowledge, driven by our curiosity about these fundamental building blocks of our universe.
And speaking of discoveries, this research you provided on how reactive intermediates are involved in creating new polymers, that's fascinating.
Oh, yeah, it is.
Can you tell me a bit more about that?
Certainly. So you see, polymers are large molecules made up of these repeating units,
Right.
and they're used in a vast array of applications, from plastics and fabrics to adhesives and coatings. One way to create new polymers is by controlling the reactions of these reactive intermediates.
Okay.
For instance, by manipulating the conditions under which radicals react, scientists can actually control the length and structure of the polymer chains,
Right.
ultimately tuning the properties of the final material.
So by understanding these reactive intermediates,
Yes.
we can essentially design polymers with specific properties.
Exactly.
That's amazing.
It is, and it opens up a whole new world of possibilities for creating materials with tailored properties for specific applications.
This is all so fascinating. It really makes you appreciate the power of chemistry and how understanding these fleeting molecules can lead to such groundbreaking advancements.
It's true. And the study of reactive intermediates continues to push the boundaries of what's possible in chemistry, constantly revealing new insights into this intricate dance of atoms and bonds that shape our world.
Well, before we get too carried away with the intricacies of this dance,
Yeah.
let's take a step back and explore another fascinating aspect of these reactive intermediates.
Sounds good to me. What did you have in mind?
Well, you mentioned earlier that reactive intermediates are involved in so many different types of reactions. I'm kind of curious to learn more about the variety of these reactions.
Okay.
You give us some examples of different reactions where these fleeting molecules play a crucial role.
Of course. So reactive intermediates are truly ubiquitous in chemistry,
Okay.
appearing in a vast array of reactions across many different fields.
Right.
One example is combustion, which is
Yeah.
the process of burning.
Right.
During combustion, reactive intermediates like radicals are formed as fuel molecules break down and react with oxygen.
Mm-hmm.
These radicals then propagate the chain reaction, leading to the release of heat and light.
Ah, so those flickering flames we see in a fireplace are actually a visual manifestation of these reactive intermediates at work.
Exactly.
Wow.
And it's not just combustion. They're also involved in atmospheric chemistry, where they played a role in the formation and breakdown of ozone, which is a key component of our atmosphere.
Okay, so we're talking about processes that are essential for life on Earth.
Yes,
And these fleeting molecules are right there in the thick of it.
precisely. They're involved in everything from the formation of smog to the breakdown of pollutants.
This is really eye-opening.
Yeah.
It makes you realize that even though these molecules are fleeting,
Right.
their impact is far-reaching and incredibly significant.
That's a great way to put it.
Yeah.
They may be fleeting, but their influence is profound. And the more we understand them, the better equipped we are to harness their power for good.
Well, speaking of harnessing power, let's delve into another intriguing aspect of these reactive intermediates.
Okay.
Their role in catalysis.
Ah, yes, catalysis.
Yeah.
That's a fascinating field where reactive intermediates truly shine.
Okay.
So catalysts are substances that speed up chemical reactions without being consumed themselves. And they're essential in countless industrial processes,
Right.
from the production of fertilizers to the synthesis of pharmaceuticals.
So catalysts are like the efficiency experts of the chemical world,
Yeah.
helping reactions happen faster and with less energy.
That's a great analogy.
Okay, good.
And many catalysts work by stabilizing or activating these reactive intermediates, allowing them to participate more effectively in the reaction.
Okay.
For instance, a catalyst might help to generate a specific radical that's crucial for a desired transformation.
Right.
Or it might stabilize a carbene,
Okay.
preventing it from undergoing these unwanted side reactions.
So it's like the catalyst is, I don't know, like a skilled choreographer
Yeah,
guiding these reactive intermediates through the dance of the reaction
exactly.
in a way that leads to the desired outcome.
Precisely.
Yeah,
And by understanding how catalysts interact with reactive intermediates,
right.
scientists can design new and more efficient catalysts for a wide range of applications.
This is really highlighting the importance of understanding these fleeting molecules.
Hmm.
It's not just about knowing they exist.
Right.
It's about understanding their behavior, their interactions,
Yes,
and how we can manipulate them to achieve specific goals.
you've got it. And the field of reactive intermediates is constantly evolving, with new discoveries and applications emerging all the time.
Right.
It's a truly exciting area of research with the potential to revolutionize many aspects of our lives.
Well, before we get ahead of ourselves and start imagining a world transformed by reactive intermediates,
Uh-huh.
I'd like to take a step back and address something that I think many listeners might be wondering about.
Go ahead, what is it?
Well, we've been talking about how important these reactive intermediates are, how they're involved in so many crucial processes, and how understanding them can lead to incredible advancements.
Right.
But I think it's fair to ask, what are the limitations?
Sure.
Are there challenges or drawbacks to studying and manipulating these fleeting molecules?
That's a great question, and you're right to point out that there are indeed challenges inherent in this field. One of the biggest challenges, as we've discussed, is their fleeting nature.
Yeah.
These molecules exist for such short periods of time
Right.
that capturing and studying them requires incredibly sophisticated and expensive equipment.
So the technology itself can be a limiting factor.
Precisely. Not all research labs have access to the cutting-edge tools needed to study these molecules.
Okay, that makes sense. Are there any other limitations we should be aware of?
Well, another challenge is that reactive intermediates are often involved in complex reaction networks with multiple steps and competing pathways.
Right.
Disentangling these intricate networks and pinpointing the role of each intermediate can be a daunting task,
Yeah.
requiring meticulous experimental design and careful analysis.
So it's not just about catching a glimpse of these fleeting molecules.
Right.
It's about understanding the entire choreography of the reaction
Exactly.
with all its twists and turns.
It's like trying to understand a complex dance routine with multiple dancers, all moving at incredible speeds. You need to be able to track each dancer's movements individually,
Yeah.
while also understanding how they interact with each other.
That sounds incredibly challenging.
It can be.
But despite these challenges, it seems like the potential benefits of understanding reactive intermediates are just too great to ignore.
Absolutely. The insights gained from studying these fleeting molecules have the potential to revolutionize fields ranging from medicine to materials science to energy production.
Right.
And despite the challenges, scientists are constantly developing new tools and techniques to probe deeper into this hidden world,
Yeah.
unlocking its secrets and harnessing its power.
Well, I'm definitely feeling inspired to learn more about these elusive molecules and the incredible advancements they're enabling.
Great.
Before we move on to those advancements, I think it would be helpful to provide a little more context on the history of this field.
Okay.
How did scientists first discover these reactive intermediates?
Right.
Who were some of the pioneers who paved the way for this research?
That's a great question. The story of reactive intermediates is a fascinating one, filled with brilliant minds,
Yeah.
serendipitous discoveries, and a relentless pursuit of understanding the hidden workings of the molecular world. The earliest hints of these fleeting molecules emerged in the late 19th and early 20th centuries,
Okay.
as chemists began to study reactions in more detail
All right.
and noticed that the products formed couldn't always be explained by the simple combination of the starting materials.
So there were clues that something else was going on, some hidden players orchestrating the reactions.
Exactly. And one of the pioneers in this field was Moses Gomberg, an American chemist who, in 1900, provided the first conclusive evidence for the existence of a free radical, a molecule with an unpaired electron.
Wow, over a century ago.
I know, right?
What was his discovery?
Well, Gomberg was studying the reaction of triphenylmethyl chloride with silver, expecting to form a stable hexaphenylethane molecule. However, he found that the product was surprisingly reactive and quickly absorbed oxygen from the air,
Interesting.
suggesting the presence of a highly reactive species.
Okay.
He correctly deduced that this species was the triphenylmethyl radical,
Okay.
a molecule with an unpaired electron on that central carbon atom.
So he stumbled upon this radical by accident.
It was a serendipitous discovery.
That's amazing.
Yeah, one that opened up a whole new field of research.
Wow.
Gomberg's work sparked intense interest in these reactive species, and over the next few decades, chemists around the world began to identify and study a wide variety of radicals and other reactive intermediates.
So from these early discoveries, the field of reactive intermediates began to blossom.
Precisely.
Wow.
And as new experimental techniques were developed, especially spectroscopic methods, scientists were able to probe deeper into the nature of these fleeting molecules, unraveling their structures, properties, and roles in chemical reactions.
It's amazing to think that these early pioneers, armed with limited tools and facing immense challenges,
Right.
were able to lay the groundwork for such a groundbreaking field of research.
It's a testament to the power of human curiosity and that relentless pursuit of understanding the world around us,
Yeah.
even at the most fundamental level.
Right.
And their legacy continues to inspire today's scientists as we delve deeper into the mysteries of reactive intermediates, uncovering their potential to transform our world.
Well, speaking of transformation, let's shift our focus now to some of the specific advancements that have been made possible by our understanding of these fleeting molecules.
Okay.
I'm particularly interested in the field of medicine.
All right.
How has our knowledge of reactive intermediates led to new treatments and therapies?
That's a great area to explore. Reactive intermediates play a crucial role in many biological processes,
Okay.
both beneficial and harmful.
Right.
Understanding their behavior has led to significant advancements in medicine, particularly in drug development and disease treatment.
Can you give me some specific examples?
Certainly, one area where reactive intermediates have made a big impact is in the development of antibiotics.
Ah, interesting.
Many antibiotics work by targeting bacterial enzymes that are essential for their survival.
Okay.
And some of these enzymes rely on reactive intermediates to carry out their functions.
So by understanding how these reactive intermediates work in bacteria,
Yes,
scientists can design drugs that specifically disrupt their activity.
exactly.
Okay.
For example, penicillin,
Right.
one of the most widely used antibiotics.
Uh-huh.
It targets an enzyme called transpeptidase,
Okay.
which is crucial for building bacterial cell walls.
Right.
This enzyme uses a reactive intermediate called a covalent acyl enzyme intermediate to cross-link peptidoglycan strands,
Okay.
the building blocks of the cell wall.
Right.
Penicillin binds to that transpeptidase enzyme,
Okay.
preventing the formation of this reactive intermediate and ultimately inhibiting cell wall synthesis.
Wow. So penicillin is essentially sabotaging the construction project of the bacterial cell wall by interfering with these reactive intermediates.
That's a great way to think about it.
Uh-huh.
And this is just one example.
Right.
Many other antibiotics target different bacterial enzymes that rely on reactive intermediates,
Uh-huh.
effectively disrupting essential processes and leading to bacterial death.
This is incredible. It's like I'm eager to delve deeper into those advancements. But for now, I think we've covered a lot of ground in understanding the basics of reactive intermediates.
I agree.
We've explored their fleeting nature, their crucial role in reaction mechanisms, the techniques used to study them, and even their historical significance.
Absolutely.
This has been a fantastic introduction to this hidden world of fleeting molecules.
Yeah.
And I'm excited to continue our exploration in the next part of our deep dive, where we'll delve into more specific applications and the future of this exciting field.
I'm looking forward to it. So where would you like to go next in our exploration of these reactive intermediates?
Well, we've talked about how reactive intermediates are involved in medicine, specifically with the development of antibiotics. But I'm curious about their role in other areas of healthcare.
Okay.
What about their impact on conditions like cancer or heart disease?
Right.
Could understanding these fleeting molecules lead to breakthroughs in treating these complex diseases?
That's a fascinating question. And you're right to highlight the potential of these reactive intermediates in tackling these major health challenges.
Gotcha.
So reactive intermediates are kind of a double-edged sword in these biological systems.
Okay.
On one hand, they can be beneficial,
Right.
playing crucial roles in these normal cellular processes.
Uh-huh.
But on the other hand, they can be harmful,
Okay.
causing damage to DNA, proteins, and other cellular components.
So it's like a delicate balance between their helpful and harmful roles.
Precisely. And when this balance is disrupted, it can contribute to the development of various diseases.
Okay.
For instance, in the case of cancer,
Right.
uncontrolled cell growth is often linked to damage caused by reactive oxygen species, or ROS, which are a type of reactive intermediate.
Ah, I've heard of ROS before.
Yeah.
They're often mentioned in, connection with antioxidants and aging.
Right.
So are you saying that these ROS can actually trigger the development of cancer?
That's right. ROS are generated naturally as byproducts of cellular metabolism,
Okay.
but when their levels become too high, they can damage DNA,
Right.
leading to mutations that can drive that uncontrolled growth of cancer cells.
So it's like a cellular sabotage mission gone wrong.
Uh-huh.
These ROS, which are supposed to be helpful in small amounts,
Right.
turn into rogue agents when their numbers get out of control.
That's a great analogy.
Okay, good.
And understanding how these ROS contribute to cancer development has led to new strategies for prevention and treatment.
Okay.
For example, researchers are developing drugs that target specific enzymes involved in ROS production, aiming to reduce their levels and prevent that DNA damage.
So it's about finding ways to, like, disarm those rogue agents before they can wreak havoc in the cells.
Exactly.
Wow.
And it's not just cancer.
Right.
Reactive intermediates are also implicated in other diseases, including heart disease,
Okay.
Alzheimer's disease, and even aging itself.
Wow. So these fleeting molecules are involved in a much wider range of health issues than I realized.
They are.
Can you give me an example of how reactive intermediates contribute to, like, heart disease?
Certainly.
No.
So one of the major risk factors for heart disease is atherosclerosis,
Right.
which is the buildup of plaque in the arteries. This plaque formation is a complex process that involves inflammation and oxidative stress.
Right.
And reactive intermediates play a key role in both of these processes.
So are you saying that these reactive intermediates are involved in creating those artery clogging plaques?
That's right.
Wow.
For example, low-density lipoprotein,
Okay.
or LDL, the so-called bad cholesterol.
Right.
It can be oxidized by these reactive oxygen species, forming oxidized LDL.
Okay.
This oxidized LDL is more likely to be taken up by cells in the artery walls, contributing to plaque formation and ultimately increasing the risk of heart attacks and strokes.
So it's like these reactive intermediates are turning the bad cholesterol even worse, making it stickier and more likely to clog the arteries.
That's a good way to think about it.
Wow.
And understanding this process has led to new strategies for preventing and treating heart disease.
Okay.
For instance, lifestyle changes that reduce oxidative stress, such as a healthy diet and regular exercise,
Right.
can help to lower the levels of those reactive intermediates and reduce the risk of plaque buildup.
This is really eye-opening. It's amazing to think that these fleeting molecules are involved in such a complex processes and have such a profound impact on our health.
It is.
Wow.
And the more we learn about them, the better equipped we are to develop new strategies for preventing and treating a wide range of diseases.
Well, this has definitely given me a lot to think about in terms of my own health and lifestyle choices.
Good.
But before we get too carried away with the health implications, I'd like to shift gears a bit and explore another area where these reactive intermediates are making a big impact, the environment.
That's a great topic to delve into.
Yeah.
Reactive intermediates play crucial roles in many environmental processes, both natural and man-made.
I'm particularly interested in their role in air pollution.
Okay.
I know that air pollution is a major concern for human health and the environment.
Right.
And I'm curious to understand how these fleeting molecules contribute to this problem.
You're right to highlight the importance of air pollution. It's a major environmental challenge.
Yeah.
And reactive intermediates are key players in the formation of many air pollutants.
Okay.
One of the most well-known examples is the formation of smog,
Right.
that hazy mixture of pollutants that often blankets cities.
Okay, so smog is a prime example of how reactive intermediates can impact the environment.
Exactly.
Can you break down, like, the process of how smog forms?
Certainly.
Okay.
Smog formation is a complex process that involves a series of chemical reactions,
Right.
many of which are driven by these reactive intermediates. It starts with the release of pollutants from sources like cars, trucks, and factories.
Right, right.
These pollutants include nitrogen oxides, or NOx,
Okay.
and volatile organic compounds,
Right.
or VOCs.
Right, I've heard those terms before.
Yeah.
NOx and VOCs are often mentioned in connection with, like, air quality and emissions.
Right.
So how do these pollutants contribute to smog formation?
Well, when NOx and VOCs are released into the atmosphere, they can react with sunlight and oxygen, forming a variety of reactive intermediates, including ozone, peroxylysyl nitrates, PANs, and aldehydes.
So sunlight plays a key role in this process, providing the energy to drive these reactions.
Exactly.
Wow.
Sunlight acts as a catalyst, triggering the formation of these reactive intermediates,
Okay.
which then go on to react with other pollutants, forming that complex mixture we know as smog.
So it's like a chain reaction, with sunlight setting things in motion.
Yeah.
leading to the creation of these reactive intermediates,
Right.
which then drive the formation of smog.
That's a great way to think about it.
Yeah.
And the problem is that these reactive intermediates, especially ozone,
Right.
are harmful to human health and the environment.
Right. I've heard that ozone can cause, like, respiratory problems and damage plants.
Yes.
So these fleeting molecules are not only involved in creating this hazy mess we call smog,
Right.
they're also directly contributing to health and environmental problems.
Precisely.
Wow.
Ozone is a powerful oxidant,
Mhm.
and when we breathe it in, it can irritate our lungs and trigger asthma attacks.
Right.
It can also damage crops and forests, reducing their growth and productivity.
This is really concerning.
Yeah.
It makes you realize that these reactive intermediates, while fascinating from a scientific perspective, can have serious consequences for the world around us.
You're absolutely right.
Yeah.
And understanding their role in air pollution is crucial for developing effective strategies to improve air quality
Okay.
and protect human health and the environment.
So what are some of the things we can do to address this problem?
Sure.
Are there ways to reduce the formation of these harmful reactive intermediates in the atmosphere?
There are definitely steps we can take to mitigate air pollution.
Right.
One important approach is to reduce the emissions of NOx and VOCs from their sources.
Okay.
This can involve implementing stricter regulations on industries and vehicles, promoting the use of cleaner fuels and technologies,
Right.
and encouraging public transportation and other sustainable practices.
Okay, so it's about tackling the problem at its root,
Yeah.
reducing the release of those initial pollutants
Yeah.
that trigger the formation of these reactive intermediates.
Exactly.
I-
And in addition to reducing emissions, we can also promote natural processes that help to remove pollutants from the atmosphere.
Okay.
For instance, planting trees and other vegetation can help to absorb pollutants and release oxygen,
Right.
improving air quality.
So it's a combination of reducing emissions
Mm-hmm.
and enhancing natural processes to clean up the air. Okay. It requires a multifaceted approach involving individuals, governments, and industries working together to address this complex challenge.
This is a lot to take in,
It is.
but it's important information.
It is.
You know, it's clear that these reactive intermediates, while fascinating from a scientific standpoint, can have significant impacts on our health and the environment.
You've summed it up perfectly.
Okay.
And I hope this discussion has highlighted the importance of understanding these fleeting molecules,
Yeah.
not just for their role in these chemical reactions, but also for their broader impacts on the world around us.
Well, I'm definitely feeling more informed and empowered to make conscious choices that contribute to a healthier planet.
Good.
Before we wrap up, I'd like to explore one more area where these reactive intermediates are playing a crucial role,
Okay.
and that's in the development of new materials.
That's a great area to delve into.
Yeah.
Reactive intermediates are essential in the synthesis of a wide range of materials.
From plastics and polymers to pharmaceuticals and electronic components.
I'm particularly intrigued by their role in creating new polymers.
Okay.
I know that polymers are incredibly versatile materials used in everything from like clothing and packaging to medical devices and construction materials.
Exactly.
How are these reactive intermediates involved in creating these amazing substances?
So polymers are large molecules made up of these repeating units called monomers.
Okay.
And the process of linking these monomers together to form polymer chains is called polymerization.
Right.
Reactive intermediates often play a crucial role in initiating and propagating these polymerization reactions.
Okay, so these fleeting molecules are essentially the architects of these long polymer chains.
That's a great analogy.
Oh.
One common type of polymerization involves reactive intermediates called free radicals. These radicals can attack monomer molecules,
Okay.
initiating chain growth. The radical then becomes part of that growing chain. And this process continues, adding more and more monomers until the polymer chain reaches its desired length.
So it's like a molecular domino effect,
Yeah.
with each radical triggering the addition of another monomer,
Yeah.
creating these long, intricate chains.
That's a perfect way to describe it.
Okay, good.
And by controlling the types of monomers used and the conditions of that polymerization reaction,
Right.
scientists can create polymers with a wide range of properties tailored to specific applications.
This is fascinating. It's
What?
like a molecular construction set,
Yeah,
where reactive intermediates are the tools that allow us to build these amazing structures
exactly.
with specific functions and characteristics.
Precisely. And the possibilities are truly endless.
Wow.
By manipulating these reactive intermediates,
Yeah.
scientists are constantly developing new polymers with improved properties,
Right.
such as increased strength, flexibility, durability, or biodegradability.
This is truly remarkable.
It is.
It makes you realize that these fleeting molecules are not just like theoretical curiosities.
Right?
They're powerful tools that are shaping the materials we use every day and driving innovation in countless industries.
You're absolutely right.
Wow.
And the study of reactive intermediates continues to push the boundaries of materials science, leading to the development of new and innovative materials that are improving our lives and addressing global challenges.
Well, this has been an incredible journey into the world of these reactive intermediates.
It has.
We've explored their fleeting nature,
Yes.
their crucial role in reaction mechanisms,
Right.
and their profound impact on health, the environment, and material science.
Absolutely.
It's been a pleasure exploring this fascinating field with you.
Likewise.
And I hope our listeners have gained a newfound appreciation for the power and beauty of these elusive molecules.
You too.
You know, it's amazing to think about these fleeting molecules, these reactive intermediates, and how they're involved in so many parts of our lives, from the medicines we take
Right.
to the materials that we use, to the air we even breathe. It's like they're kind of these unsung heroes of the chemical world working behind the scenes to shape and to transform our world.
That's a great way to put it.
Yeah.
They may be fleeting, but their impact is profound.
Right.
And as we've seen, understanding their behavior is crucial for advancing our knowledge in so many different fields, from medicine and material science to environmental science and beyond.
Well, speaking of advancing our knowledge,
Yeah.
I'm curious to know what the future holds for research on reactive intermediates.
No.
What are some of the cutting edge areas of research in this field,
Right.
and what breakthroughs are scientists hoping to achieve?
That's a great question.
Yeah.
The field of reactive intermediates is constantly evolving, with new discoveries and applications emerging all the time.
Right.
One really exciting area of research is the development of new and more sophisticated techniques to study these fleeting molecules.
Can you give me some examples of these new techniques? What are scientists doing to push the boundaries of what we can see and understand about these molecules?
Scientists are constantly developing new tools and techniques to probe deeper into the world of reactive intermediates.
Okay.
One promising area is ultrafast spectroscopy,
Okay.
which uses incredibly short laser pulses to capture snapshots of reactions happening on timescales of femtoseconds.
Right.
That's 1/4 of a second.
Wow, a quadrillionth of a second.
Yeah.
That's mind-bogglingly fast.
It is.
What kinds of insights can we gain from studying reactions at such incredible speeds?
So by using these ultrafast techniques, scientists can essentially freeze reactions in time, allowing them to observe the formation and decay of these reactive intermediates in unprecedented detail.
Right.
This can reveal crucial information about the mechanisms of reactions, including the order in which bonds break and form,
Right.
the energies involved, and the factors that influence reaction rates.
So it's like watching a slow-motion replay of a chemical reaction,
Yeah.
but on a time scale that's almost impossible to imagine.
Exactly.
Wow.
And this level of detail is crucial for understanding how reactions work at the most fundamental level, which can then inform the design of new and more efficient catalysts,
Right.
the development of novel materials with tailored properties, and even the creation of new drugs and therapies.
This is incredible. It seems like the possibilities are truly endless.
They are.
When we can study reactions with such precision and clarity.
Yeah.
Are there any other cutting-edge techniques being used to study reactive intermediates?
Another exciting area is computational chemistry,
Okay.
which uses computer simulations to model and predict the behavior of molecules,
Right.
including reactive intermediates. These simulations can provide valuable insights into the structures, energies, and reactivities of these species, complementing experimental studies and guiding the design of new experiments.
So it's like having a virtual laboratory where scientists can run experiments and test hypotheses without even setting foot in a lab.
That's a great way to think about it.
Uh-huh.
And with the ever-increasing power of computers, computational chemistry is becoming an increasingly powerful tool for studying these reactive intermediates, allowing scientists to explore complex reaction networks and predict the outcomes of reactions with greater accuracy.
This is truly remarkable. It seems like the combination of these advanced experimental techniques and these powerful computational tools is giving scientists an unprecedented level of insight into the world of reactive intermediates.
Absolutely.
What are some of the specific applications that scientists are hoping to achieve through this research?
The potential applications of research on reactive intermediates are vast and far-reaching.
Okay.
One area where this knowledge is already making a big impact is in the development of new catalysts.
Right.
Catalysts are substances that speed up chemical reactions without being consumed themselves. Uh-huh.
And they're essential in countless industrial processes,
Yeah.
from the production of fuels and chemicals
Right.
to the synthesis of pharmaceuticals and materials.
Okay, so catalysts are like the efficiency experts of the chemical world,
Yeah.
helping reactions happen faster and with less energy.
That's a great analogy.
Okay, good.
And many catalysts work by stabilizing or activating these reactive intermediates,
Right.
allowing them to participate more effectively in the reaction.
Okay.
By understanding how reactive intermediates interact with catalysts, scientists can design new and more efficient catalysts for a wide range of applications.
Can you give me some specific examples of how this knowledge is being applied to create new catalysts?
Certainly.
Okay.
One area where this is making a big impact is in the development of catalysts for green chemistry,
Okay.
which aims to design chemical processes that are more environmentally friendly and sustainable.
Right.
For instance, researchers are developing catalysts that can activate carbon dioxide,
Uh-huh.
a greenhouse gas.
Allowing it to be used as a building block for the synthesis of useful chemicals and fuels.
Wow, so turning a harmful greenhouse gas into something useful.
Exactly.
That's incredible. How are reactive intermediates involved in this process?
Well, carbon dioxide is a very stable molecule,
Right.
and it takes a lot of energy to break its bonds.
Okay.
However, by using carefully designed catalysts,
Yeah.
scientists can activate carbon dioxide,
Right.
creating reactive intermediates that can then participate in other reactions, leading to the formation of new products.
So it's like the catalyst is giving carbon dioxide a little kick to get it going,
Uh-huh. Yeah.
transforming it from a stable molecule
Right.
into a reactive one
Yes.
that can participate in these useful reactions.
Exactly.
Okay.
And this is just one example of how understanding reactive intermediates is leading to the development of new and innovative catalysts that are transforming the chemical industry and making it more sustainable.
This is truly inspiring. It's amazing to see how fundamental research on these fleeting molecules is translating into real-world applications that are addressing global challenges.
Absolutely.
Yeah.
And in addition to catalysis, research on reactive intermediates is also driving innovation in materials science.
Okay.
By understanding how these molecules behave,
Right.
scientists can design new materials with unprecedented properties such as increased strength, flexibility, durability, or biodegradability.
Can you give me some specific examples of how this knowledge is being applied to create new materials?
Of course.
Okay.
One example is the development of self-healing materials,
Okay.
which can repair themselves when damaged.
Cool.
These materials often incorporate reactive intermediates that can be triggered to polymerize or cross-link when a crack or damage occurs,
Right.
effectively healing the material.
Wow, self-healing materials.
Yeah.
That sounds like something straight out of science fiction.
I know, it's pretty cool.
How do reactive intermediates make this possible?
So these materials typically contain microcapsules filled with a healing agent, which is often a monomer that can be polymerized by a reactive intermediate
Right.
when the material is damaged.
Yeah.
The microcapsules rupture, releasing the healing agent.
Okay.
The reactive intermediate is then triggered,
Right.
either by exposure to air, light, or another stimulus,
Okay.
causing the monomer to polymerize and fill the crack, repairing the damage.
That's incredible. It's like the material has its own built-in repair kit ready to go when needed.
Exactly.
Are there any other examples of how reactive intermediates are being used to create innovative materials?
Another fascinating area is the development of bio-inspired materials,
Okay.
which mimic the properties and functions of natural materials, such as wood, bone, or spider silk.
Okay.
These materials often rely on reactive intermediates to assemble and organize the building blocks,
Uh-huh.
creating complex hierarchical structures with remarkable properties.
So we're talking about learning from nature and using that knowledge to create new materials with properties that rival or even surpass those found in the natural world.
Exactly.
All right.
And reactive intermediates are playing a key role in this process.
Wow.
Allowing scientists to control the assembly and organization of molecules at the nanoscale,
Right.
creating materials with unprecedented strength, toughness, and flexibility.
This is truly remarkable.
It is.
It's amazing to see how something as fleeting as a reactive intermediate
Yeah.
can have such a profound impact on the materials we use and the world around us.
Absolutely.
It seems like we've only just scratched the surface of what's possible in this field.
You're absolutely right.
Wow.
The study of reactive intermediates is a vibrant and exciting field with a bright future.
Uh-huh.
As we continue to develop new tools and techniques to study these elusive molecules and gain a deeper understanding of their behavior,
Right.
we can expect to see even more groundbreaking discoveries and applications in the years to come.
Well, this has been an incredible journey into the world of reactive intermediates.
It has.
We've explored their fleeting nature, their crucial role in reaction mechanisms, and their profound impact on a wide range of fields, from medicine and material science
Right.
to environmental science and beyond.
Absolutely.
It's clear that these molecules, though short-lived,
Yep.
are powerful agents of change,
Yeah.
shaping the world around us in countless ways.
It's been a pleasure exploring this fascinating topic with you.
Likewise, it's been great.
And I hope our listeners have gained a newfound appreciation for the beauty and complexity of the molecular world
Yeah,
and the incredible power of these fleeting molecules.
I know I have.
Great.
And for our listeners who are eager to learn more, I encourage you to delve into the resources you provided, explore the latest research, and never stop asking questions about the world around you.
Good advice.
The world of chemistry is full of surprises.
It is.
And these fleeting molecules are proof that even the most transient of species can have a profound and lasting impact.
Well said. Until next time, keep diving deep and keep exploring the wonders of the molecular world.
Cheers to that.